Right, so we are in Vleesbaai. This is at Fransmanshoek on the eastern side of the little peninsula. This area is mostly covered in not mobile dune sands, but recently deposited marine origin sands. And the area we're in now, we can see there has been a bit of disturbance. So the top layer of the sand has been removed, and a bit of the underlying geology has been exposed here. I don't know if this is going to be super obvious in the video, but we can see there, we can see like little cleared tracks in between, and there we can also see like the substrate is changing a bit, from going from sandy and then it becomes a lot more rocky. And there's a little like a borrow pit in front here, which I'm just walking to, which will show the underlying geology for this specific spot, which is what we would call in the east Nahoon Formation Eolianites, and on this side, if I remember correctly, is Vleesbaai Eolianites. So here we can see like rock fragments already, and we don't think this was really exposed too much at the surface. But here you can see, I'll show you a quick section at the bottom. Sorry, this is not a terribly well narrated video, but anyway, let's see, where's that little section? Here we go. So this was obviously disturbed back in the day. This would not have been exposed too much at the surface, but here you can see is like a, I don't know, like brecciated sandstones of the Table Mountain group, like these things. I actually think maybe Alice has made a video about this already, but anyway, we can just cover it again, because the point of this is this is sort of like reinforcing what Haley's been telling us about dune topography being controlled to a large extent by the underlying geologies of like fossilized dunes. So here we probably have an example of that happening. So underneath all of this stuff, we would have had some Table Mountain sandstones, which we can see outcropping towards the bottom of the peninsula all around. And then this is sort of, might have been back in the day a bit deeper down, a contact between the sandstones. So you can see like a very big component of sandstone. So this might have been a little outcrop of the sandstone. And then some kind of, I'm not sure if this would have been a fossilized dune or something, or some kind of chemically precipitated calcium carbonate that's now like cementing the stuff together. But you can see like large chunks of sandstones, and then this stuff, which is similar to what I think we saw at the drift sand site in Port Elizabeth. So this might be a similar type of depositional environment. So potentially this is not Nanaga. Oh, sorry, the Vleesbaai Eolianites, although the stuff at the top might have looked a bit more like that, but potentially this is a much older deposit that was sort of laying down on top of the Table Mountain sandstones. Anyway, so yeah, in this spot specifically, the soil seems to be quite shallow. So you can see these plants are all growing pretty much with their feet inside of Table Mountain sandstones. And then there's a very thin veneer of recent sands on top. So here we can see, obviously, the sand has been deposited in between the crevices of the rocks. But yeah, there's definitely like a little mix of things going on here. So calcareous deposits, calcium carbonates, Table Mountain sandstones, and then what we would assume might be more recent marine origin sands. But the plant community doesn't really change much. So this is the stuff that we see here is pretty much exactly the same as what we've been seeing all around us, which is dominated by Holocene sands. So yeah, we might have to grapple with that a bit to really try and understand like how do these like localized little outcrops of TMS and potentially older carbonate deposits, how do they affect communities, plant communities in these dune landscapes.